Revolutionary applications and innovative scenarios. Smart contracts create new application scenarios. The increase of specific needs necessitates a multi-chain future. Introduction. From the previous chapters, you have learned about blockchain technology as well as its security risks and main categories, but you may know little about the important technologies derived from it. In this chapter, you may dive deeper into the blockchain that completely revolutionizes the way that applications are developed. Smart contracts. The idea of smart contracts was first proposed by Nick Szabo in 1994 in his paper, The Idea of Smart Contracts, which took vending machines as an example to describe a more automated way of enforcing the process set by the original contract. With the booming of blockchain technology, smart contracts are now able to achieve more diverse application scenarios. Smart contracts are programs automatically executed on the blockchain. They automatically execute instructions under predetermined conditions, without the need for third parties or intermediary agencies. Theoretically, applications based on smart contracts will be more open and transparent than centralized applications. Ethereum is the second largest cryptocurrency by market cap. It was launched by Vitalik Buterin in 2014. Ethereum is often part of people's conversation when it comes to smart contracts. With nearly 10 years of development, the concept of smart contracts has driven multiple innovations in the entire blockchain industry, among which are numerous ICOs based on the ERC-20 standard in 2017, the explosion of decentralized finance in 2020, and the NFT craze in 2021. Now, Ethereum has developed into a blockchain that enjoys the most robust ecosystem. If you want to write smart contracts on Ethereum and create decentralized applications, you must write them in Solidity. You can imagine Solidity as a communication language for specific systems. Smart contracts automate complex processes, and the security of blockchain prevents them from being tampered with or deleted so that all actions can be executed more efficiently according to specific standards. The future of multi-chain. Blockchain networks could be divided into three categories: public chain, private chain, and consortium chain. Currently, the most mainstream and widely recognized category is the public chain. As blockchain technology is recognized by a wider population, more and more people want to use this technology to solve corresponding problems. If each blockchain is likened to a highway, then public chains are like roads that never intersect, with each having its own destinations. This is the case for multi-chain. Why is multi-chain important and destined to be the future? With the rapid development of decentralized applications in the past 2 years, the number of users and market demands have increased. As a result, the existing blockchain architecture is unable to fully support such high usage demands and more customized application scenarios. Therefore, more teams began to create a more efficient blockchain network according to their own vision and needs. It sounds reasonable to design corresponding solutions for specific scenarios, but it is never easy when actually implementing it. This involves designing a new operating system from scratch. When building the system, several factors should be considered, including how to achieve a trade-off between decentralization, security, and scalability, what algorithms should be used to encrypt data, and what consensus mechanisms can help verify the correctness of the submitted information in a more efficient way. Public chain projects emerge one after another, creating different ecosystems. Since 2020, we have seen many innovative public chains emerge with their own unique ecosystem, despite all the hardships in the development. For example, Flow focuses on introducing mainstream IP to develop an NFT ecosystem. Cosmos is committed to building an Internet of Blockchains. Polygon is compatible with Ethereum's programming language. Solana, a high-performance public chain, claims to load 60,000 transactions per second, and Avalanche achieves both scalability and interoperability. These are only some of a wide variety of public chains. In addition to these, There are EVM-compatible chains based on Ethereum and Layer 2 scaling solutions based on Ethereum mainnet, among which the representative projects are Optimism and Arbitrum, which use Optimistic Rollup, and ZK Sync that adopts ZK Rollup. In order to boost ecosystem development, many public chains have invested heavily in attracting developers and users. The race has long started. Are there any other applications that can solve this problem? Cross-chain bridges are created to address it. The cross-chain bridge promotes data interaction and asset transfer between ecosystems. Each blockchain network has its own consensus mechanisms, tokens, smart contracts, and data structures, making it impossible to exchange data with one another. It's like the scenario when an American and a Chinese want to chat in their own language. It is impossible for them to communicate smoothly without a translator. The cross-chain bridge enables interoperability between different blockchains, and developers can collaborate with each other to deploy applications that are most suitable for the blockchain network. Definitely, the cross-chain bridge is critical to the future of the blockchain industry. Modular blockchain. The modular solution is to divide the blockchain into The modular solution is to divide the blockchain into various stacks according to different functions, including execution, settlement, consensus, security, and data availability. Different module handles different tasks. A common practice is to separate the execution layer, security layer, and data availability to better solve the impossible triangle problem: scalability, decentralization, and security. Modularity increases system flexibility. Each blockchain should be responsible for the execution, security, and data availability itself, which caused bottlenecks at scaling. The advantage of modular architecture is that it improves the flexibility of the system while maintaining better scalability because each module handles different tasks. Under this architecture, it is easier to maintain and update the functions, making it a more cutting-edge technology. Celestia is a representative of the modular public chain, but it is still far from being actually implemented. At present, there is no modular public chain that has been practically implemented, but the most representative modular blockchain is Celestia. It is a pluggable consensus and data availability layer. Simply put, by separating the consensus mechanism from data, an application based on a specific consensus layer, node network, can be deployed directly on multiple chains. Celestia separates the consensus layer and the execution layer, allowing specific applications to be optimized according to their own needs. Theoretically, programs based on this architecture have better flexibility, security, and scalability. However, Celestia is still in its early stages. The testnet has only been released in mid-2022, and the incentive test and the mainnet will not make major progress until 2023. What's more, though the underlying technology has been live, it takes time to develop and build the project as well as the whole ecosystem. Conclusion. With the growth of the number of applications and users, the original blockchain technology is unable to support the evolving needs. Many new chains have hence emerged to solve specific problems, like Cosmos that is committed to developing the Internet of Blockchains, Polygon that is compatible with the programming language of Ethereum, and the high-performance public chain Solana that can load up to 60,000 transactions per second. Multi-chain will inevitably become the future. In addition, the infrastructure of cross-chain bridge that intends to unlock the liquidity between different ecosystems is highly valued. But admittedly, there are many security issues that need to be addressed. The technology of modular blockchain is still in its early stage. Splitting blockchain into modules based on different functions could achieve better scalability and flexibility. Celestia is currently the most representative blockchain to implement modularity, but it has quite a long way to go. Blockchain technology is booming in recent years, enabling the creation of many innovative applications. With the explosive growth of the number of applications and users, public chains designed for specific scenarios emerge. We are sure to see more innovation and progress in blockchain and usher in a future where blockchain becomes the mainstream. Key takeaways. 1. The first smart contract was implemented based on Ethereum. It has then created a myriad of innovative applications, such as DeFi, NFTs, and dApps, which have truly unlocked the potential of the blockchain. 2. The multi-chain future is sure to happen because different applications have different data storage and needs. The cross-chain bridge is one of the important infrastructures in a multi-chain future. 3. Modular blockchains distinguish stacks based on specific tasks and functions. Although it involves a more complicated development process, it can better improve the flexibility and scalability of the system. Related articles. 1. What are smart contracts? 2. What are blockchain bridges and how do they work? 3. What is Cosmos Atom? * Crypto investment involves significant risks. Please proceed with caution. The course is not intended as investment advice.